Okay, so we have this integration problem here involving a quadratic trinomial. So let's see how we'll solve this. So we have it as the integral of 2x plus 3, everything over 9x squared plus 6x plus 5 with respect to x. So our best bet here would be to first check if we can apply an algebraic substitution, a use substitution, whereby the derivative of the denominator will be exactly what we have as a numerator. But let's be sure of what we are doing. So derivative of the denominator will be 18x plus 6. So this is not the case because the numerator is 2x plus 3 and the derivative of the denominator is 18x plus 6. So that cannot easily happen, except we are going to manipulate the numerator in such a way that it will be a constant multiple of the derivative we just found. So if we can write this in form of this, I think it will help out with our substitution. So let's do that. So writing 2x plus 3 as a constant multiple of 18x plus 6. So it's going to be this way. So it's going to be 2x plus 3 will now be equal to a bracket 18x plus 6 then plus b. Yes, this is how we can write this as a constant multiple of 18x plus 6. So let me open the bracket on the right hand side. So I have 2x plus 3 equals a times 18x will be 18ax, then plus times plus is plus, then a times 6 will be 6a, then I have my plus b. Then now I can equate corresponding coefficients. So I have 18a having a variable x and 2 having a variable x. So I'm going to equate them because they are corresponding here. So that'll be 18a will now be equal to 2. So 18a will now be equal to these 2. That will be my equation 1. And then the constant, I have 6a plus b having no variable will be equal to 3, also a constant. So that'll be 6a plus b will now be equal to these 3 here, and that will be my equation 2. So from equation 1, I can easily solve and get value for a. So if I have 18a equals to, dividing both sides by 18 cancels 18, then my a will now be equal to, so the a will now be equal to 2 here 1, 2 here 9. So a will now be equal to 1 over 9. So my a will now be equal to 1 over 9. Then in equation 2, I can substitute the value of a, which is 1 over 9, into equation 2, and I will get my value for b also. So I'll be 6 bracket 1 over 9, close bracket, plus b equals 3. And then further simplifying, 6 times 1 is 6, 6 over 9 plus b equals 3. Then this is 2 over 3 because I can reduce it. 3 here 2 and 3 here is 3. That will be 2 over 3. So that's 2 over 3 plus b equals to 3. Then multiplying through by 3. So times 3 times 3 times 3. This cancels out this one. I'm left with 2 plus 3 times b is 3b equals 9. Then I have, collecting like terms, 3b equals to 9. This plus 2 becomes minus 2. Then 3b, okay, let me write that one over here. So 3b will now be equal to 7. 9 minus 2 is 7. And dividing both sides by 3. So my b equals 7 over 3. So now, finally, I've written this as a constant multiple of the derivative of the denominator, and I've finally gotten my value for a. My a is 1 over 9, and my b is 3 over 7. So I'm going to rewrite this integral. So it's now going to be the integral. So rewriting the integral, I now have the integral of, I'm writing this, but I'm putting my value for a, which is 1 over 9, bracket 18x plus 6, close bracket, plus, what's my b? My b is 7 over 3, so that's 7 over 3. Everything still over this 9x squared plus 6x plus 5, still with respect to x. So finally now it's looking okay. It's looking more standard than before. We can work with this now. We can now work with this. So here, remember what we have, that we're going to apply. Remember, if you have 7 plus 5 over 9 is still the same thing as 7 over 9 plus 5 over 9. Yeah, so I can rewrite this as this. I'm going to do the same thing, apply the same logic here. So rewriting this, I'll have the integral of 1 over 9 18x plus 6 over 9x squared plus 6x plus 5, then plus this one over this one too, 7 over 3 over 9x squared plus 6x plus 5, then still with respect to x dx. So now integrating separately, I'm starting with this and then I'll continue with this. So integrating separately, I will have the integral of this first of all. So we're writing that the integral of 1 over 9 18x plus 6 everything over 9x squared plus 6x plus 5 dx plus the integral of this one too, 7 over 3 over 9x squared plus 6x plus 5, still with respect to x also. So we're going to integrate this and then come back to this later. So now let's focus on this one now. So integrating this, so I can pull 1 over 9 out. So pulling 1 over 9 out, I have 1 over 9 and then the integral of 18x plus 6 over 9x squared plus 6x plus 5 dx. Then I can now use my u substitution. My u will now be equal to the denominator, u equals 9x squared plus 6x plus 5. Then of course the u dx with respect to x now, the u dx will now be equal to 18x plus 6. And then if I should treat the u dx as a fraction, I'm putting this over 1, I can now cross multiply. I have 18x plus 6 dx equals to the u, then dividing through by 18x plus 6. So my dx is now equal to, so the x is now equal to the u over 18x plus 6. So I'll be replacing the dx here with this value du over 18x plus 6. So rewriting this one, and I have 1 over 9 of the integral of 18x plus 6 over u, since I've made this one my u already, then I now have dx is now equal to du over 18x plus 6. So du over 18x plus 6. So finally this can now cancel out this. I'm left with 1 over 9 and the integral of 1 over u, because you still have 1 here, 1 over u, then du. But don't forget that for 1 over u, the integral, remember that 1 over x is equal to ln of x. So we're applying this shortcut here now. So the integral of 1 over u will now be ln of u. And of course, we still have our 1 over 9 outside. So that 1 over 9 times ln of u is 1 over 9 ln of u. So, and what is our u? Our u is what? 9x squared plus 6x plus 5. So that will be 1 over 9 ln of 9x squared plus 6x plus 5. So that is that for this one. So this one here, the integral of this has been gotten. What do we get? We got this 1 over 9 ln of 5. So now the next one is to find the integral of this second guy here. So we're going to do that one now. So for that one, so for this guy, I'm pulling this one out and I have one left here. So pulling 7/3 out, I have 7/3 coming out, and then the integral of 1/9x squared plus 6x plus 5, then with respect to x. So integrating this second guy here, this one, we can complete the square down here because we cannot apply a u substitution here. There's nothing to eliminate here. It's just going to be there, and it will be another variable and that stress for us there. So we would, maybe I can rewrite this as I can complete the square here. So I will now have it this way. Let me complete the square for the denominator. So completing this one, the square, I can have it as 9 bracket x squared plus 6x/9 plus 5/9. Yes, then I'm trying to complete the square for this one here. So we now have 9 bracket x squared plus 3 can divide 6 to get 2 with your x, and 3 9 is 3. I only reduce this one, then plus 5/9, and then finally we can now have 9 into x squared plus 2/3x. I will divide this one by, if I divide 2/3 by 2, I'll get 1/3, and I'll square it, add it to this side, 1/3 squared. Then I'll have it here also plus 5/9, then minus that same 1/3 squared, which is 1/9. Then close the main bracket. Then if I should continue from here, so here I can now factorize here. So I now have 9 into x plus one of these, which is 1/3. Oh, I still have the bigger bracket outside, squared. Then 5/9 minus 1/4 is 4/9, so that's plus 4/9. Then close the main bracket, and I'm going to multiply through by 9. So 9 times this still gives me 9 bracket x plus 1/3 squared plus 9 times this gives me just 4. And I can still simplify this one. 9 is 3 squared. 3 squared bracket x plus 1/3 squared plus 4. And this one, since they both have the power 2, I can pull one out and leave all of them in the bracket. So 3 bracket x plus 1/3 all squared. Then I can have it this way. So opening, this is plus 4, then opening the bracket, 3 times x is 3x, plus times plus is plus. 3 times 1/3 is 1. Then I still have my square outside, then plus 4. So this is what I get after resolving this, after completing this, completing the square for this value here. We got 3x plus 1 all squared plus 4. So now we can now replace this value with this one and now finally integrate. So I'm going to rewrite this one in terms of this. So I'll have it as the integral 7/3 and the integral of 1/, I'm not putting this again, I'm putting this value here, 3x plus 1 squared plus 4, 3x plus 1 all squared plus 4 dx. Then I can write 4 as 2 raised to power 2. So I now have 7/3, then 1/3x plus 1 squared, then plus 2 raised to power 2 dx. So here I decided to write 4 as 2 raised to power 2 because I want to apply a trigonometric substitution here. And from what we have, we know that for trig substitutions, whenever we have the integral of 1 over x squared plus a squared, the a being our constant, and here 2 is our constant, we can just apply a direct substitution here. So just apply this one here and we are good to go. So let's just apply this one. So applying this, so for this value here, we're going to say it will now be 7 over 3 times whatever we get after applying this substitution. Okay, let me write this one out. So here my a is 2 from here, and my x is what? My x is the whole 3x plus 1 squared. But before even applying the trig substitution, I could still further resolve this. I can make this my u. I think that's the best bet. So doing that, before I even apply the substitution, I can make this one my u. If this one is u, to make it look more simplified, u equals 3x plus 1, and then the u dx will now be equal to 3, and then this one is 0. We can now apply. So treating this as a fraction, I can now cross multiply. The u times 1 is the u equals to 3 dx, then dividing both sides by 3, I have dx equals to the u over 3. So I'm replacing this dx with the u over 3. So I now have 7 over 3, and the integral of 1 over u, this is now u. I'm doing this so that I can make my trig substitution much easier. So u squared plus 2 squared, then we now have dx now being the u over 3, then pulling the 1 over 3 out. If I pull the 1 over 3 out, and I have 1 over 3 times the 7 over 3 outside, and then the integral of 1 over u squared plus 2 squared, then the u. So this will now be 1 times 7, 7 over 9. This one now becomes 7 over 9. So this is now 1 times 7, that's 7 over 9. Then the integral of 1 over u squared plus 2 squared du. We can now finally apply our u substitution, our trigonometric substitution. It now blends in well. So this 2 is the constant a. So a equals 2, and then the x is u, and then we are good to go. This is the formula. So writing out the formula, or following what is being written here, so it's now 7 over 9, and then following what is here, times 1 over, what's the a? A is 2, then tan inverse of, what's my x? X is u over, what's the a? 2, then of course c. Then of course I can open this one, so this one will be 7 over 18 tan inverse, what is my u? My u is 3x plus 1, so that's 3x plus 1 over 2, 3x plus 1 over 2, then plus c. Mind you, I'm not multiplying this with this. This shouldn't be here at the initial stage. I just added it. So then plus c rather. So now this is what we got after integrating this other one. So now I have so many solutions here. So this is for the second integration problem. Remember, we did the first one. We got the value. The second one, we got this value for the second one. So this value is for this. So combining them, we're going to have, so for this we got a particular value. So for this we got a particular value. This was what we got. So we got 1 over 9 ln this same value here. So rounding up, so finally the concluding part. So for this, we got 1 over 9, then 9x squared plus 6x plus 5 plus, for this, we got this. So for this, we got this. So that's plus 7 over 8. Let me put this down a bit. That's 7 over 18 tan inverse of 3x plus 1 over 2 and then plus c. So that's it.